Okay. The absorption of visible light or ultraviolet light by a chemical compound will produce a distinct spectrum. When ultraviolet radiations are absorbed, this results in the excitation of the electrons from ground state towards higher energy state. The basic principle of spectrophotometry is based on Beer-Lambert's law. According to this law, when a beam of monochromatic light passes through the medium, a portion of light is absorbed. The extent of absorption depends upon the wavelength of absorbed radiation, thickness of medium, and concentration of solution. Incident radiation I0, solution of thickness, concentration C, transmitted radiation IT. Absorption of radiation by test sample in the form of solution. According to Beer-Lambert's law, log I0 over IT equal to ECL, A equal to ECL, E molar extinction coefficient, C concentration of solution in mole per liter, L part length, thickness in cm. For a given species in a given instrument, A proportional C, observance is directly proportional to the concentration. Varying continuously the wavelength of calorimeter filter, wavelength corresponding to maximum observance is first determined, which is used for further measurement. Absorption wavelength lambda max. If we plot the calibration curve of concentration versus observance at experimentally determined lambda max, the curve should be straight line passing through the origin. Instrumentation, radiation source, wavelength selector, solvent, sample, detector, indicator, various components of the spectrophotometer. Radiation source, the most common source of radiation is tungsten filament lamp. The emitting capacity depends on the temperature of filament and wavelength of radiant energy emitted. The most common source of radiation is tungsten filament lamp. The emitting capacity depends on temperature of filament and wavelength of radiant energy emitted. Essential characteristic of radiation source should be able to emit a spectrum which contains all wavelength over region to be used. It must generate beam with sufficient power for ready detection and measurement. This should be appreciable changes in the intensity of radiation at different wavelengths. The intensity of the radiation should not fluctuate for long intervals. Monochromator, wavelength selector. This is an accurate source of getting monochromatic light and is used for selecting an appropriate wavelength region. Test sample and optical material. The sample to be analyzed by absorption measurements is placed between the monochromator and detector. Detectors and indicators. This is device that changes radiant energy into electrical signal to the radiant power observed by sample. Application of UV visible spectroscopy, qualitative analysis, identification of unknown compound. An unknown compound can be identified by comparing its spectrum with known spectra Harty's rule states that compound having the similar structure would have similar absorption spectra. Detection of functional group and extent of conjugation. This technique is applied to detect the presence or absence of chromophore, observes electromagnetic radiation, the presence of bone at a particular wavelength, give an idea for identifying chromophore. Quantitative analysis. Absorption spectroscopy has been effective in the determination of concentration of solution as 10 to the power minus 6 to 10 to the power minus 7 meter, which cannot determine by gravimetric or volumetric method. Small amount of ammonia can be determined calorimetry. Geometric isomers can be determined by UV visible spectroscopy. Spectrophotometric measurements have been useful in the determination of equivalence point of titration.